The objective of this talk really is just to teach you a little bit about F#. It's really level 100, 200. It's not going to go into depth on the language. Talk about C#, the evolution of the language, where that's going, how you see it changing, where some of the features are coming from, and really look at whether F# might actually be a better fit for you for the types of programs you're writing today, why it might be a better fit, how to help you make a decision whether it's worth investing time even looking at the language. And I'm hoping at the end of it, I've at least encouraged you to spend a few hours maybe over the next few weeks trying out the language, playing with it, and just making that decision yourself. So just a bit about me. My name's Isaac Abraham. I've been using C# and .NET since .NET 1.0, so almost 20 years now, and using F# for the last 5 or 6 years. I'm from London, live in Germany now though. I'm the founder of CIT. We're a company that do F# consulting, training, development, and also MVP these days for F#. In terms of my background, I suspect it's somewhat similar to many of you here, in that I've been doing C# development, WPF, Silverlight, ASP.NET MVC, web forms, console applications, and I went through the whole thing of learning about Solid. Anyone know what Solid is? Just one. Yeah, okay, a few of you. Test-driven development, unit testing, those sorts of things, design patterns, all of that. So I'm hoping that what I talk to you about today, you won't see it as coming from sort of an ivory tower perspective, but someone who's actually been writing C# for many years. And I sort of started using F#, and everything I'm telling you today is based on that sort of experience and perspective. Why am I really giving this talk? Oftentimes you'll see people talk about something they're really passionate about, and it can sometimes be difficult to understand what their real motivation is. For me, the reason why I use F# isn't really for F#, it's a means to an end. The real reason why I use F# is because I am passionate about writing quality software. So I like the idea that I can release code that I feel confident about, that I know what it's been doing, that I feel that I was able to deliver a good solution for my customers. On top of that, I'm passionate about writing on .NET. I'm assuming that many of you here are using .NET in some way, shape, or form today, in .NET Core. So I believe that .NET Core is a really, really great place, particularly today, to be writing software. And on top of that, I think if you're writing on .NET Core, F# is a fantastic language. So think of it from the top down rather than from the bottom up. I'm not using F# for the sake of it, but as a means to an end to write high quality software. What I'm not going to do today is show you all of the features of F#. So oftentimes you'll have seen talks, and you can look them up on YouTube or probably at NDC here, that go through all the great features of F# that either are slightly different from C#, that aren't in C#, and so on. So people will talk about active patterns and type providers and so on and so forth. But I don't think that's a particularly effective way to actually to show people why they might want to use F#. More often than not, it's just, well, I've seen all these features. Yeah, that sounds interesting, but how does it all come together? Why would I want to give up a language that I'm really good at, that I can use in second nature, go through the pain of learning something from scratch? So I'm not really going to do that today. It's probably a bit different to some of the talks I give where I'm sort of coding for most of it. Most of this will be demos, and a couple of demos and mostly slides, to be honest. What I will tell you is there's one slide here, which is how do I really get to the secret and the answer of what F# is. And this is really it. I don't think I can show you all the features today and you're going to leave today and say, yeah, that looks cool, but I'm not going to start using it tomorrow. So the real thing is, try it out for yourself. I'm going to show you some things today that might encourage you and hopefully build up a bit of trust as to why you can do F#, why you can use it, how you can use it. But the truth is, at the end of the day, you're going to have to make that decision of whether you want to invest a bit of time in learning the language as well and seeing if it fits for you. I would also say, I think, oftentimes, particularly with C#, and I'll talk about this a bit later, that we see there's more and more features in the language. And as I've started using F# more, I've realized it's not actually about the number of features you have, but it's the right mix of features. So it's equally important as what features you do have, as what ones you don't have in the language as well. And I'll give you some examples of that as how some features actually, there's a tension between them. And that if you add one feature in, it diminishes the impact of another one. What I really want to do is talk about how F# makes me feel from an emotional point of view, why it works for our company, how we've benefited from it, and why you might want to do it. So not so much on the deep dive technical level, but more at a high level. Just a quick show of hands, so I get an understanding of what you guys, your background is. Who here is doing any F# today or looked at it at all? In production? Okay, good. C# or Visual Basic.NET? Yeah, pretty much everyone here. Anyone who's doing software development not on .NET? Okay, what was that? What? C, okay, straight C, excellent. Any other ones? JavaScript? Python? Okay, cool. Good. So what I'm really going to focus on for the next, 50 minutes or so is what is and isn't functional programming, try and dispel some myths, tell you a bit more about the language, why you want to be trying it, and importantly, how you can actually get started. So I'm going to just fire up a demo, which I should have really started beforehand, but let's do it now. So unfortunately, because I'm a bit of a cheapskate, I'm running this demo on the free Azure service, which means that sometimes it takes a minute or so to start up. So what I'm going to show you, we'll leave that until it starts, is basically a web application that is written in F#. It's hosted on Azure. It's running in ASP.NET Core, on .NET Core 3, and writing with React, Redux, and JavaScript as well. So once Azure warms up this site, we should be able to see it. Let's fire that off again. Save change. If it doesn't start, then I'll skip on and then I'll come back to it once Microsoft. There we go. Excellent. Okay, good. So, who here is based in the UK? Okay. We all know everyone is obsessed by house prices in the UK. Everyone looks at them. Everyone's state of mind is based on if house prices are rising or not, and depending on whether you're already in the house market or not. So what I wrote is a simple application that basically downloads prices that the UK government publish every month, every transaction, and lets you basically do some searching. So we're using things like blob storage, Azure Search, table storage, and so on. So I can do things like type in the name of a town or a city or any keyword really, and we'll get some things like find has typing. I can hit search, and once it wakes up, then it will actually show me some results in a table. I can do things like sorting. We get faceted search on the left, so that's the sort of things that you get with Amazon when you do a search, and it shows you the categories or the manufacturers on the left. We can also do things like click on a little button and we'll get a pop-up. You'll see we also get Google Maps integration here. So pretty much the sort of things that you would expect to see in a normal application, really, a normal web app. I can also do things like click on a postcode on the right. And what that will now do is do a search based on locality. So now it's showing me results based on ones that are closest to this one I just clicked on. I can click on the map. And this is just to show you that I can actually do some programmatic work with this. So these pins are actually based on those properties, based on their longitude and latitude, and I can mouse over them and it will show me every property that was sold, how much it was sold for, and so on. I can also do things up here, like I'm searching for a postcode at the moment, and you'll see as I type, if it's an invalid postcode, I actually get some real-time red sort of squiggly there that says it's not valid. So I'm somehow doing some kind of validation here. That's checking if it's a valid postcode or not. So let me go back here and ask you now, from that application, if I was to say that was 100% F#, who would believe that? It's not, but 75%? 50%? 25%? Okay? So the answer is that's 92% F#. The only file that's JavaScript is a Webpack config file. Everything else in there is F#. There is not one line of C#. There's no C. There's no JavaScript that we've handwritten. And there's one CSS file and one HTML file that's a shell. Everything else in that app was F#. Access to Azure, the web development, the view code, all of it. So I'm not going to talk about this today. I'm doing a 2-hour workshop tomorrow afternoon where we're going to write an app that looks similar to that in the afternoon. So if you're interested in finding out more, you can come along. But for now, just believe me when I say that's true. So given that I've hopefully at least established that you can write end-to-end apps, the real question now is, what is F#? Why would I want to use it? So F#, first of all, is a general-purpose programming language. And I'll come back to this time and time again today to the point that you're going to hate me, probably. It runs on .NET Core. You can interoperate with C# and VB. So you can use all the NuGet packages that are out there. You can use all the .NET framework libraries. You can talk to SQL using System Data or Dapper or any other libraries that are out there. It's a strongly typed language, although it doesn't look like it, but it's actually stronger than C# in terms of the type safety. It's got a really powerful compiler and a very, very, very lightweight syntax. This is the last point, though, that it's functional first, and this will be the theme that we come back to again and again today. What do I mean by functional first? So when I ask you about what is functional programming, oftentimes people will say these are the sorts of things they're thinking of. If I was to ask you in C#, what are the sorts of features you use today that you would think of as functional programming? Lambda expressions, maybe? Pattern matching, like switch expressions? The idea of composability? Anything else? No. So in reality, what it really comes down to are these two things here. Expressions and immutability. That's, to my mind, what the real core of functional programming is. And what we'll try and do in the next 40 minutes or so is look at really what that means, how that impacts on F# and C#, and which one might be a better fit for you. So. Immutability is just the idea that you create some data and it never changes, ever, ever, ever. You create a value, you can't modify it later on. Now, at first glance, that sounds a bit weird. We know that we always have to change state, but there are actually ways of doing this in languages like F# that say you can take a copy of a value, make some changes, and then get a new value, a new version of it, but keep the old one as well. Oftentimes, people talk about some of the benefits of that, like things like multi-threading and things like that that are kind of not everyone uses. But if you think about it, even something as simple as passing a value to a method, maybe that one of your colleagues owns, you're not maybe responsible for that part of the system. You might give them an object, they might change it without you even realizing. If you use immutable data, that's no longer a concern. Or how many times have you written the code and you've got a variable that's public, or a method or a member that's public, and someone says, oh, make it private, that way no one else can change it or see it. If you start working with immutable data, all goes away. You don't need to worry about exposing values because no one can change them anyway. Yep?
It's like with the strings.
Pardon?
Like with the strings, you know?
Yeah, exactly. Like with strings, but think of this more as classes with all the properties on them that you can't change any of them. Yep. Does anyone here know what an expression is compared to a statement? Okay, so basically what this really means is the idea is of does anyone know what void is in methods that return void? So with F#, there's no void. Every method you call must return some data. You must always get a result. And that has several implications, but generally what it tends to lead to is code that's easier to test. If you're ever doing unit tests, for example, you have to sometimes say, I'm going to call a method. It doesn't return anything, and the way that I prove that this method has done the right thing is I check some properties on the class. I check some state of the object. With expressions and sort of pure functions, the idea that you just return some data, it's really easy. You give some data to a function, you get some data back, and then you check is it the right value or not. So this makes things a lot simpler, actually, to reason about. Why F#? When F# first came out, this was the kind of tagline that they started with. And I think it was a useful tactic. because it was basically, they were targeting things like maths and science problems and difficult, challenging things that maybe C# wasn't particularly well suited to 10, 15 years ago. I would now say to change it to say, I want to solve simple problems, line of business apps, enterprise applications, maybe just single page web apps, but with really simple code. So this is not about F# is only suitable for hard things, but it's a general language that you can use for simple things as well. So the sales pitch that I often talk about is things like lowest development costs. So we do F# 100% in what we do today. We're writing web apps, Windows services, ETLs, all those sorts of things. We find it's quicker for us to develop apps than it would have been using other languages. We get fewer bugs. Our customers seem to be happier. Refactoring code is pretty easy. And for me, as a company owner and a team of developers, we find that they're happier because they are able to deliver more for their customers more quickly. But this is really a key thing, this increased confidence. I don't know about you, but I hate this feeling of releasing applications or new versions of an app and being really scared and nervous that I've introduced bugs that I haven't found out about. Maybe I didn't write enough tests, or maybe I try to put something in and I'm really not sure that it's going to do the right thing. F# gives me a great deal more confidence. It makes me actually enjoy what I'm doing because I have the confidence that it's the right thing. Whether or not I'm doing the right thing for the customer based on the requirements is a separate issue, but at least between me and the keyboard and the computer, that kind of chance of things going awry definitely reduced. Also, F# has this notion of scripting. So if you come from a Python background where you can get a REPL and you can start doing interactive programming, F# has that as a first-class sort of approach. So you can start doing scripting. You don't need console applications to test things out and explore data. You can just fire up a file, start typing, and explore a domain really, really easily. And it also lets you work closely with customers. So this is an unusual one people tend not to think about, but F# is really good at domain modeling. And it has a very lightweight syntax that means it's easy for non-technical people to actually read what you're doing. And I'll hopefully show you that in a little bit. But the idea is that I've actually sat down with customers, opened up some empty script file and said, right, let's try and model your domain. You have a customer. Each customer has a set of orders. Each order has an ID. The ID might sometimes be there. Maybe it's nullable, certain things like this. And you can actually go through it with the customer and they can build up this domain with you interactively almost. And you can try things out very, very quickly. So it has a very rapid feedback cycle. Customers quite like that. Has anyone heard of this phrase, the pit of success, before? Okay. Are any of you leading teams at the moment, like running teams of developers or anything like this? Have you ever been on a project where you've put in a kind of a framework or a paradigm that you've said, this is how we're going to do things. I've done a couple of examples. I'm going away for a few days, maybe on holiday, maybe to another project. And then you come back and it's all just gone. No one's been able to follow what you said, or they didn't listen to you, or it's just, you come back and you're like, how did you do that? I thought it was obvious what was going on. That's like the opposite of the pit of success. It's hard to do the right thing, and it's easy to go off the path. It's easy to do the wrong thing. So if you imagine that like, this point up here is going to be where things are good, and things down here are where things go wrong, it's really easy to go wrong here. It does need a bit of wind, and this ball is going to roll down. It's hard to keep it in the stable point at the top. What we want to do is flip it and put it into this pit of success where good things happen here, and to go out of there, to do the wrong thing, is really hard. That's where F# really shines. It allows you to encode rules in your code so that actually your team will actually get warnings and errors from the compiler before they do the wrong thing, before they actually launch into production. In terms of history, F# had I think a few years ago it was in a different position to today. You know, we had this notion of things like designer-first tooling. Visual Studio, you'd create a form, you'd drag on controls and so on, file new project. We had code generation, so things like Entity Framework 4. If you remember the early days of that, you had the drag and drop designers, WinForms, all of those things. Everything was closed source. It really didn't play well with F# because Microsoft, you know, they couldn't invest in all the same level of tooling that C# has into F#. So you didn't have the drag and drop designers for WinForms. You didn't have drag and drop designers for Entity Framework. So it meant that F# sort of had to carve their own way. There was a lot of tools that people wrote that did similar things, but written from the ground up. Nowadays in .NET Core, it's all very different. You know, we have this notion of code-first programming. We're trying to rely less on drag and drop designers. We have the .NET SDK. We don't really want to rely on code gen anymore. Everything is open source. This is actually where F# has always been. More from a code first point of view, simple APIs that are easy to understand, command line tooling with maybe some GUIs on top, but not relying on that. Who here is actually using .NET Core framework? Okay, so to be fair, F# works on both .NET Core and .NET Full Framework, so there's no difference there. If you've got .NET Core, you just have to install the SDK and you've already got F#. So whether you know it or not, you've already installed it. Microsoft are definitely committed to F#. There was kind of a feeling a few years ago that this wasn't the case, but they're really investing into it. We've got a growing team in America and in Europe now for people working on the tooling, on the compiler team. I think the difference is really, though, that F# community and the ecosystem does have a little bit more diversity, I would suggest, than C# ecosystem. There are certainly some tools and libraries that aren't simply, essentially, the Microsoft MVC libraries or API, web API, but maybe wrappers on top of those things. So there are libraries like what I showed you before with the Safe Search app. There's basically an F# library that sits on top of ASP.NET. So we get all the benefits of the security, of the performance improvements that Microsoft are introducing, but we can still take advantage of F# as a programming language that we as developers interact with. Spent a couple of minutes now on just going through some sort of, maybe some myths about F#. The one I'm going to say again, and this will probably be the last time, is that it's a general purpose programming language. A lot of people think in the past that, when should I use F#? You know, I've got to find that perfect use case for it, or I've got to find some really hard problem that makes F# worth the effort of learning. But if you ever hear that phrase, or if you think to yourself, what's the area that F# really shines? Where should I really use it? The answer is programming. Really is that simple. So that's where F# is great. It's a general purpose language. You can do data access, web apps with it, Windows services, Docker apps, you name it. Some other things I hear sometimes, it's too hard. Or it's only for the maths and science or the really complicated things. As I said before, it probably was a useful tool for Microsoft early days to differentiate F# from C#, but I think it's actually damaging the language now. It's not hard, but it is definitely different from C#. And what I'll talk about very shortly is some of the distinctions and maybe helping you understand why should you look at F# rather than C#. Okay, so the real challenge is to unlearn what you've learned. And this is where I see people that are looking to F# that come from C#. This is the real challenge they face, is if you're expecting to start looking at F# and not have to learn anything new, or I want to still write code the same way as I've done in C#, you'll generally either be disappointed, frustrated, or annoyed at yourself for wasting time. F# is a different way of doing things. The question is whether it's a better fit for you or not. Okay. I wanted to look at some examples in C#. And this is not a character assassination of C# the language. I'm a big fan of it. But just to illustrate some of the things about hard and different. Imagine I'm a C#2 developer, or C#3. I've come from 2008, and I've jumped forward in time, and I'm looking at C#8. You know, you can do these range indexes in C# now. You can basically say, I've got a string or an array, and I want to take a subset of it. What items will this give me back if I say 1 to 3? Is that going to give me A to C? B to D? Any ideas?
B to C.
Yeah, exactly. Who thought it was B to C? Just one person, okay. So this is because it's 0 based when it starts, but it's 1 based when it ends. Okay? I thought originally this was the length, but obviously not. What about this one? hat3 to hat0. Anyone know what that is? Yeah. Does this mean that C# is hard, or that maybe just not seen it before? I'd never seen this before, but it actually means go back 3, and then starting from the back, take the 0th element. Interesting. What about 5, 5? We're going to give back E?
Nothing.
Exactly, nothing. Who thought it was going to give back nothing? A couple of you, 3. So it's about 1/10 of the audience, right. This doesn't mean that C# is hard, but it means that you've not been exposed to it before, not really sure what it's doing. Does anyone know what this guy does? Has anyone seen this before? What do you think it does? So this basically says, if object keys is null, run this code and assign it back to object keys. If it's not null, don't do anything. So it's kind of a null coalesce and an assignment in one. I'd never seen this before. Yeah. Does this mean C# is hard or a bit different, something new here? This was a sample that came out when C# 8 first launched. I had to think about this really hard to understand what this code does. So we're calling a method called getCustomersAsync, which returns asynchronously an enumerable set of nullable customers. We're going to go through each of them, and then we're going to switch on each customer. If the customer is null, give back null. If the customer is a tuple of null and some non-null string, return back a string with Mr. or Mrs. second part. Otherwise, get the first element of this string. And how do I convert from customer to a tuple? Where did that happen? Don't really know. And then at the end of it, you get back a nullable string as well. I mean, if you've not done this before, this to me is quite hard to understand. But again, it's new features in C# that maybe we've not been exposed to. This is an old example of C#. Someone at Microsoft did this code, and they said, oh, this is really cool. This is like F#y. Got Elvis, null coalesce, ternary, not equals to, sorry, that was null coalesce, ternary, other ternary, end quote. This is not what F# is about. So if anyone has told you this is what F# is about, is putting together loads of crazy operators, not true. This is, to me, unreadable. But maybe your mileage may vary. It's another one I read from a really well-known C# blogger and community member. Has anyone looked at C# 8 default interfaces? People don't know what they do. It's like you can make abstract members on interfaces now. How do you use them? When do you use them? I'm trying to read the docs on this, and I have no idea what I'm looking for. This is an experienced C# dev. Didn't know what it meant. Here's stuff that I find hard, just so you know that I'm not some sort of genius mathematician. I scraped through my A-levels at maths. That was about the extent of it. Does anyone here do SharePoint? Yeah? I find SharePoint really hard. If any of you are like consultants in SharePoint, come to me afterwards. I'd love your help. JavaScript. Anyone here like JavaScript and the way it handles equals? Lovely. That's hard. German grammar. So I live in Germany. I'm still learning the language. German grammar is hard, especially if you come from English. .NET Core versioning. Has anyone looked at this SDK nonsense? Version 2.2.6 to version 2.2.7, but it goes backwards from 2.2.401 back to 2.2109. How does this work? Say again? Yeah, exactly. Yeah, exactly. So unusual, I would say. That's hard. Here are some reasons that I have heard from people not adopting F# that you may find, to be honest. You don't know what benefits it offers. Don't have the time to learn it. That's probably the most common one I hear. Or your company don't allow it. What these are really saying is cost-benefit analysis. I can't invest the time and the cost and the risk of trying something different, so we'll stick with what we've got. That's an option. That's totally reasonable. The tooling definitely isn't as good as C#. It's not bad, but it's nowhere near as good as C#. Some people don't like the syntax. I mean, okay, fine. And this last one, I can't get my head around it, and that really leads to a couple of slides later about the features in F# and whether you really grok what it really tries to push. If you go the way F# leads you, you're going to love it. If you try and fight it, you probably won't. F# actually doesn't have any of these operators. So all of those ones I saw before. Null coalesce, the crazy assignment one, the Elvis operator, ternaries, don't have any of them in F#. So if anyone tells you that F# is this crazy language with loads of operators, it's not true. The only actual one it has that isn't in C# really is the pipeline. And it's a really, really simple but powerful operator. So if we imagine here we've got a function called add, which takes in 2 numbers. And I want to assign that to answer. What you can also do is this. So instead of the 10 on the right, I've pushed it to the left, and then I do this pipeline and say pipe 10 into add 5. Right? Doesn't seem that nice or that useful. What about something like this? I want to add 5, multiply by 2, add 3, multiply by 4. Have you ever seen code like this where you've got the bracket, 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 and, going on forever? Well, with the pipeline, it just becomes that. Yeah, and now it's 10 add 5 times 2, add 3, multiply by 4. Easy. Yeah, and it's not just about mathsy stuff. I could do stuff like this. Load customer 10 from the database, validate them, generate a PDF, email it to someone. So I can make a nice workflow now. And it's just pure, simple functions that we're going to compose together. There's actually a feature request in C# to add pipelines into the language. It's been going on for a while now. It's actually really hard because there are certain features in F#, the syntax, the way it handles things like curried functions that you don't have in C#. Porting something like the pipeline doesn't really work. It really doesn't work nicely, so it's quite a difficult one to add in. I expect it will never happen. But we'll see. So let's talk a little bit about C#. And just acknowledge, first, it's a great language. It's got loads of features, fantastic tooling. Any language that you compare to C# will come up second best in terms of tooling. Even without ReSharper, even without it. Scala's nowhere near it, Java's nowhere near it. C# has got fantastic tooling in Visual Studio. It's got huge user base, rapidly growing feature set. And even if you look at the language features, you can see that it's been getting more and more so-called functional programming features. You had sort of C#3 with all these guys. C#7 brought in tuples and some basic pattern matching. C#8 has now got switch expressions. Is anyone doing C#8 today? Okay, so have you seen switch expressions? Yeah, okay, great. C#9 is even going to get more. You're going to get records, probably, which we'll talk about in a minute, and maybe even union types, which are both from F#. Look at people like this. John Skeet is saying he's replacing a load of switch statements with switch expressions. Yeah, he likes this stuff. He's applying more and more of it into his own code. Nullability changes, another feature from from C#8 he's applying in. Look at this one from Rich Campbell. This is the guy that does .NET Rocks. Top three features in C# that will change the way you write code. This is not someone saying that they will make code a bit easier, but actually change the way you write code. These are the sorts of fundamental changes happening in C#, and they're basically equivalents or very similar to features that are in F#. So then why should I bother using F# at all? Yeah, C#'s getting all these features. Many of them are similar to F#, so we've got pattern matching, which people from F# used to talk about years ago. You've now got something similar in C#. Tuples, you've even got nullable reference types now. Why should you bother even investing any time when you've got all the features? Why not just wait a couple more years? Eventually, C# will get even more. And this is now where it really comes to the crux of it. It's taken, half an hour to get here. This is not about which language has the most features or which one doesn't. It's about which language fits the way you write code. So if you see this now, this table here, if there's one slide you want to take away, this is the one. If you look at this and you say, I do everything on the left, you might want to leave at that point. So if you like writing code that's like statement-oriented, so everything is voids, you like mutating things by default, you write stateful classes, you do imperative, inheritance, side-effectful code, F# is probably not going to be a good fit for you. Probably won't be. If, on the other hand, you like doing things with expressions, so you've tried switch expressions, you like them, you're doing local functions maybe, lambda expressions, things like that. If you've tried doing immutable data structures, things like that, or records, F# might be a nicer fit. Is anyone here doing link? Come on, yeah. If you like that sort of way of programming, F# is like, that's the default way of writing code and composing everything. And reuse through composition rather than inheritance. So if you, rather than doing inheriting, you're taking interfaces, implementing them, building them together, you might find actually that F# is a nicer way of doing things. Has anyone heard of this thing called like single responsibility principle, this SRP? So what you end up doing with this principle. It basically says your classes should do one thing and one thing only. And if you take that to its logical sort of conclusion, every class should only have one method then that does one thing. Well, if that's all you're saying, you may as well just pass functions around, in which case F# is actually a natural way of doing things because you just pass functions around, you don't pass objects around. And this comes back to it again, what I said earlier, where I said it's not about how many features a language has, it's that it has the right blend of features. So things like implicit conversions, mutability, cyclical references, those features sort of push against other ones. So when I talked about pipelines earlier on and said people might want to add that into C#, you can't really do it easily because pipelines needs another feature of F# called curried functions. And curried functions doesn't work if you have method overloading. So you're almost like, it's like you've gone down one path. You can't do breaking changes in C#, so you can't stop how things work. So the only option is to bring in somehow cut down versions of these features. There's nothing else you can really do. To give you an idea of some of the things you would lose if you move to F#, these are all the things you either can't do or are difficult to do. So you can't do things like protected. You can't create an object and assign half of it. You have to assign everything up front. Yep. On the one hand, that might be a bit annoying. You know, what if I don't know what the values are up front? Well, there are ways around that. Excuse me. On the other hand, it means if you deal with that up front, you don't have an issue later on of accessing some value, and it's null. Can't happen. Cyclical references. So people hate this in F# when they first come to it. You cannot access a value unless it's already been defined. And you can't access any types unless they have already been declared further up in the project. So it actually has this kind of downward-facing dependency. So why would I want to do that? Well, firstly, it means things are quite simple. If you want to know where your dependencies are, you just look upwards. Everything at the bottom is the top level of the end of your file, and everything at the top is the low-level parts of your code, effectively. They can't see anything else. And it also stops you doing spaghetti code, where you have A that calls B that calls C that calls D that calls A. Yeah? Everything follows in one direction. So the things you can do is curried functions, which I'll show you with a quick demo later on. Pipelines, proper type inference. So is anyone here using var at all? Yeah. So in F#, basically everything can be var. You don't have to put in type declarations basically anywhere. The compiler will figure it all out for you 9 times out of 10. So you can write entire apps, declare your types, write your functions. You don't have to put in any type declarations, which really is a time saver and a very lightweight syntax. So let's go back here. In terms of like the object side of F#, it does have it because it runs on top of .NET. So it needs to be able to do classes and interfaces to run with the rest of .NET. But the only parts that you'll normally use are things like stateless objects. You won't really make mutable objects. You might use interfaces. Probably won't use mutable data or events. And you definitely won't use inheritance or nulls or overloads. These are things like if they're dear to you, you probably will find it quite difficult, or it might be a bit of a challenge to start looking at F#. These are, I think, the key sort of changes for F#. You learn to trust the compiler. What do I mean by that? Rather than writing code and thinking about it all yourself, you tend to be a bit lazy, if I'm honest. I get quite lazy when I'm writing F# because I basically write some types, I write some functions, and then I just wait for the warnings and the errors in the compiler, normally errors. You fix the errors, carry on. Do some more, you fix the errors, you carry on. You run the code, 9 times out of 10 it works first time. The difference is you spend a bit more time writing the code, but you don't spend much time debugging because normally you fix the problems up front. The compiler will catch a lot more errors, and I'll show you a quick demo at the end if we've got time that will just sort of illustrate how that works. I'm going to skip through some of these. I sort of talked about this already. Expressions, they let you write code more succinctly, they catch more bugs. I'm going to give you an example here. So this is some C#. So this is a function that is going to describe someone's age. I'm going to pass in the age, and I'm going to say if the age is less than 18, set the description to child, otherwise set it to adult, and then write out, you know, hello, you are a child or an adult. Now there are a couple of bugs in here that I've sneakily left in. Can you see any of them? Say again? Yep, that's one. There's another one.
Greeting
Excellent. So there's that. So I've assigned it to the wrong value. So if it's 65, it's going to print out, adult, you are a nothing. And as you also pointed out, I've missed out the else case. Now, C# can't tell me about this. It's not that C# is a bad language, it's this notion of statements. The compiler doesn't understand that there's some relationship between all these different cases. It just knows if the age is 18, do something. Otherwise, if it's 65, do something else. It doesn't realize there's this relationship between the two branches. You can do this in C#. You split it into a method that does that check. And now you'll actually get a proper compiler support here. If I miss out this last case, the compiler will give me an error. It will say you can't miss this out. You have to provide a default value if you don't pass into those two. And it's impossible for me to assign to the wrong guy age description or greeting because it's all coming in one place. It's this atomic action. So we've already solved 2 bugs. Now you might look at this and think, nah, I'll never do that. Imagine a team with maybe 8 developers, some juniors, some seniors, writing hundreds and thousands of lines of code. In F#, this is exactly how things work by default. So if else is actually an expression. So I can say let age description equals, if age is less than 18, then child. If it's less than 65, then adult, else OAP. So that's sort of built into the language. So if you find yourself writing code like this, it's that's how things work. Does anyone look? I think there were a couple of people here that said they're using switch expressions. So this is something in C#8. You had switch number before, where we could say, if the number is 1, then output is hello break. If it's 2, then output equals this, blah, blah, blah. And in C#8, you can now do this. You can say, I want to switch on the number. If 1, then hello. If 2, then foobar. 3, goodbye, otherwise default. And it all gets assigned to output. So this is like distilling the difference between a statement, or 4 statements in this case, and 1 expression, where it all gets assigned to a single value. And in F# it's exactly the same. Syntax is a bit different, but it's again match number with. 1 goes to hello, 2 goes to foobar, and so on. So if you're using things like this in C#8 and you think this is awesome, in F#, this is the default way of working. This is like, there is no switch statement. Everything is a pattern match expression. Is anyone doing async await sort of stuff in C# today? Have you ever done this before, where you create an async method and you forgot to await some task returning method? You get a warning here. It's quite nice. It says, because this call is not awaited, blah, 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 consider applying the async operator. So the compiler is actually good here. It knows that you've forgotten to do an await, and it gives you a warning. And it knows that because this function returns task of t. Yeah? Great. Unfortunately, it doesn't do it anywhere else. So here I've got a method that's returning a string. I've forgotten to assign it, though. I'm just calling it. Compiler's not going to warn me here, because in C#, all the defaults are around statements. It doesn't assume that you're writing code to return values. Whereas in F#, you get a warning here. It says, hang on, you called this function that gives back text and have not assigned it anywhere. The result of this has type string and is implicitly ignored. So it's actually warning you there's some result, you're ignoring it. Please do something. So either I could assign it to a value, or I can do this ignore. And I actually am saying to the compiler, I know it returns something, ignore what it's giving back, I'm telling you I know better. So if you're writing code that is normally sort of returning values that you throw away, you'll probably find this really annoying. You have to put ignore everywhere. But if you want that protection, because you're writing code that returns values and you want to work with values, F# is a much better fit because it will tell you when you've done things wrong. Another thing, you don't have void in F#. So you can't do this in C#. I can't call a method that returns void and assign it to result. You get an error. In F# you can actually do that because we have this thing called unit, which is actually an object. It's actually a thing that you can throw around and you can pass around to other types and other values. So here I can actually say let result equals print my name, and it will actually assign it to unit. Why is this important? Have you ever done anything with tasks and you've got task of t and the non-generic task guy? So you've got 2 versions. With F# you don't need that. There's just one type of task. If you don't return any value, it's just task of unit. So straight away, everything gets simpler in that regard. Right, working with nulls. Is anyone doing anything with non-nullability in C#8 today? I had a look at it. So this is how it works. You put this question mark at the end. And now the compiler is going to give me a warning that says string might be null, and I'm assigning it to a non-nullable reference. You shouldn't be doing this. But you can override this. You just put an exclamation mark at the end, and then it turns off the compiler check. Not so fond of that. In F# you can't do this. That's a completely different type. This thing called string option is basically saying the string might be there, but it might not be there. That's like saying in C#, assign the value 1, 2, 3 to a string. You can't do it. They're completely incompatible. Yeah. C# also introduces this thing called flow analysis. So if I pass in this nullable string and I do if it's not null, then he'll let me check it because he knows I've done a null check. But otherwise, outside of that, he knows it's still non-nullable, right? Nice, interesting. But it's also confusing, adds some complexity, not only to the language, but also to you as developers. What if you're doing something a bit more than just this? You're calling another method that's doing the check. Then you've now got to think, well, what if that one does it? Where does the check happen and so on? In F#, there's no such thing as this flow analysis. You basically take in a string, and even if I check if it's null or not, that type there, that text, is always optional. You're not allowed to just blindly do dot and access a value that might be missing. You can't do it. How do we do it in F#? We have this thing called pattern matching. So I can say match the text with, if it's some text, then I'm allowed to check it. Otherwise, it's nothing. Give a default value instead. Yeah? So in this case, now the compiler's made it impossible for me to accidentally dot into it. You literally can't have null references with this sort of approach. You can get them in corner cases, but basically if you're writing normal F# code, you won't get null references. Just to sort of sum up what I've really been getting at for the last 10, 20 minutes or so, is you have all these corner cases in in C#, like async await, where you have things like this extra checking that you get, but you don't have everywhere else. F# you don't really have that. You have this thing called void, which is like a hole in the type system in C#. F# doesn't exist. No such thing as implicit type conversions. You can't go from int to float without an actual proper type check and a conversion. And you don't have any of these crazy operators in F#. It's just basic functions, basic methods, basic types. You learn these sort of fundamental rules, and then everything just works. It really is. So it's a very different approach. Rather than having custom language support for different use cases, F#'s approach is rather we have a general set of features that apply to all of these different cases. So once you learn them, you can basically do everything. And this is the last part we'll talk about, and I'll do a little bit of scripting after this, just so you can see the kind of the development sort of cycle and how it applies. So let's do a simple domain modeling exercise, right? We have a customer object. Every customer can be contacted in one of several ways: email, post, or telephone. One of, not all of them, one of. And all of those, you can contact the customer by email or post or telephone. How do you model this? So here's version 1. Who would do this? I'll create a class called customer, and I'll put the fields on there across all of those. So I have a telephone number, address line 1, address line 2, postcode, and email address. So you've got one class with all the fields on it. Who would do that? Anyone? No? Okay. You probably do something like this. You'll have a method called contact, and we'll say, if the telephone number isn't null, this guy must be a telephone customer, and I'll call it. If the address line 1 isn't null, this must be a postal customer, therefore I'll post it. Otherwise, it must be an email address. You'll get what I'm doing here? Nothing too crazy. Why wouldn't you want to do this? What's wrong with this approach? Yeah, could all be null. Brilliant. Anything else? Yeah, exactly. Could also forget, you might have just address line 1 populated, but not 2 or the postcode. And if you look at this, it's not clear. You can't look at this class and understand the business rule we're trying to encode. We're trying to say only one of these can be populated at any one time. Can't know that from this. What about if we said, I know what we'll do, we'll have an enum that will add on to the class, that will then say contact method is telephone or address or email address, and then we'll just add it to these, and then we'll check first. So we'll say, ignore that. We'll say, check the contact method. If it's telephone, then I'm going to call the telephone number. If that method, that value is address, then I'll do this. If it's email address, then do that. Anyone will do this? Yeah, seems reasonable. Still got the same sort of issue there, haven't you? In that there's nothing to stop someone looking at this class, setting this value to telephone, but leaving that null and filling in those ones. But we can't really solve that, to be honest, easily, except you can in C#. Who would do this? I'll make an abstract class called contact method, and then I'll have a telephone subclass, an address subclass, and an email subclass. And then I'll use polymorphism, and I'll put my contact method on there, and I'll have a void polymorphic method called contact. Who would do that? Anyone? Yeah, exactly. Yeah, or with interfaces. Okay, great. So we've now got this thing where we've got to have an interface and say iContact method. Same sort of thing, really, right? And then you probably have a factory, probably some sort of strategy pattern to go through it. Right, we're already now into the worlds of design patterns. Okay, fine. Let's have a look how this would look in F#. And you've waited probably 40 minutes for me to actually type anything. Now we'll do some code. So I'm going to fire up Visual Studio, and let's actually type it from scratch. So let's remove this guy. Right, so the first thing I want to do is model my customer. Is that okay at the back? Yeah, okay, good. So let's start by creating a customer object. So I'm going to say type customer equals name, string. Let's say they've got an age as well. And then I'm going to say contact method. What do I put here, right? Don't really know. This is going to have the bits, whether it's telephone, email, or post. So what we're going to do is create what's called a union type. Contact method is either, that's what that pipe means, we'll say it's telephone of number. So telephone number, which it's either a telephone which contains a number as its data, or it's an email address of address, which is a string, or postal of, and now I'm going to create a record in line, where I'll say line 1 is a string, line 2 is a string, or postcode is a string. More or less see what's going on there? Yep. Okay. And now I can go back here, and I can say contact method. So there's my record. So let's create one of these, see what it looks like. So let's create a customer, which we're going to call Isaac. Name is Isaac, and in fact I'll do it all on one line. So age equals 40. Contact method equals, let's do a telephone. 49, 1, 2, 3, 4. Okay. What have I done wrong there? Oh, right, fine. It's too big for an integer. Okay, fine. So what this is saying is now I've created a record. Interestingly, I've not actually told it what type this is. I've not said here, this is a record of type customer. And if I mouse over this guy, he knows it's a customer. How does the compiler know that? Because he's looked above in the scope of the entire app, and he said, well, the only type that has those fields is customer. Therefore, this must be a customer. And because in F# you can't have circular references, it can't be something that's been declared later. It's only stuff that's already been declared. So you're starting to see some of the benefits you get by having some of these other constraints. Now I'm going to write my contact method, which is going to take in a customer. So this is the guy that's going to know whether to say hello, whether to call them, whether to send an email, whatever. And in fact, just before I do that, I'll just show you one of the nice features is this REPL that we get in F#. So let's pin that to the right. So, whoa, that's quite big. Let's just resize that. That's okay, right, good. So what this thing on the right is, does anyone use like the immediate window in C# when you're running? This is like an immediate window, but it's there while you're typing in code, while you're editing, while you're actually creating code. So I've actually just sort of executed it, and I can even send a value in. So I can send Isaac in, and now it's actually created that down the bottom. And I can do some things now. I can say, well, let's have a look at Isaac's name. I can highlight that, and then I get down at the bottom, Isaac. So you can imagine I could actually start to explore this, create some types. Let's create a function, see if it works or not. So I'm going to create my function called contact, and I'm going to say match customer dot contact method with. So I want to depending on what type of contact method I've got, I want to do different logic. Cool, good. So we'll say if it's a telephone number, I want to print the text calling number. So this guy here represents the telephone number that I entered before. It's like unwrapping it. Or I could say if it's an email address. Let's go back there. Okay. Interestingly now, if I mouse over, can you see that green squiggly? It's saying that I forgot to do postal. I haven't dealt with that yet. So the compiler is actually guiding me now to do the right thing. So let's fill in postal. And I'm just going to go on a new line. Address dot line 1, address dot line 2, address dot postal code. Another interesting thing, if I mouse over customer, he again knows that that's of type customer. How does he know that? Because I've used the field called contact method. And that's the only record in scope that's got a field called contact method. Therefore, this must be a customer.
How would you
So you can, then you can just put in a type annotation. So then something like this.
you have another object contact?
Yeah, absolutely.
It's still know that that's
It will take the first one that's been declared then. And then you can say, actually, I know better. It's this guy. Or if you start using more properties, he'll again say, oh, there's only these ones that could use all of them. It must be that. Also notice that there's no return type here. I've not had to specify it. But I can see there, look, this guy, contact, says, give me a customer, I will give you back a string. Let's try it out. So I've got my contact function. I can now say contact Isaac. Boom. Yep. So now I've actually just explored. I didn't need a console app, didn't need a web project. I just fired up a file, tried to experiment. Let's look at a slightly more complex example very, very quickly. Let's assume that telephone, I said, actually, I need to now add in a region, like a country code beforehand. How would I do that? So let's say it's either UK or foreign. And if it's foreign, we're going to have a pre-dial code, which is an int. So I've created this type. Now I'm going to add it onto telephone. So I can say, right, telephone is now the combination of country and the phone number. Yep. Straight away I get an error down here. So I have to add in that. Works again. But let's say I wanted to be a bit smarter. I wanted to have a specific method, a specific handler for UK numbers, different message. That's easy. I could say, if it's UK and a number, calling home. And let's just fix this. Okay. Look now, I get another compiler warning. I handled UK, but I've forgotten to handle foreign. Please fix it. Let's go and fix that one. And let's be a bit of a cheat. And we'll say foreign 1. So only ones that have the foreign number 1. Well, let's actually do 49. Then I can say calling Germany. Oops. Now I get an error saying you didn't handle foreign 0. So it will keep going until it's exhausted all the cases, where in my case, I could just be lazy and say, well, if it's some foreign, I don't care what code, always fall into this case. So it lets you actually model your domain and then sort of progressively capture all the different cases up front. Okay. Right, where's the clicker? Almost out of time, so that's good. I've shown you that. Not going to show you that. I want to show you this. So to me, this is where F-sharp's strengths are. I know I've only shown you sort of the high-level bits of it. One, this idea that you trust your code. Because it uses things like expressions and immutability, which we've seen already how that can resolve certain bugs, and also these sum types or union types, which you just saw. That's something that currently you can't do in C#, the idea that something is one of a number of cases. Does it really nicely in F#. You get to feel productive. You've got the REPL that I showed you very, very briefly. Type inference, again, I showed you briefly this really nice lightweight syntax. It's community-led, open source. There's commercial support. Microsoft are backing it, so you have that safety net. And also you trust the platform. So cross-platform, if you're using NetCore, you can use it on Linux, you can use it on Mac, you can use it on Windows. You have a huge ecosystem. If you're on .NET already, you are not giving up anything in terms of libraries by moving to F# or trying it out. You can use basically every existing library. If you've got .NET Core, you've already got F#. If you've got .NET Framework and Visual Studio, 99% of the time you'll already have F# installed. You've got Visual Studio users here, I see. Rider, anyone? Code, yeah. All of those work, so no problems. How do you start? So I give people 3 different ways. One is what I call logic islands. Let's say you've got some bit of business logic in your code, in your app. Maybe it's not going to the database. It's just something you want to model and run some business rules on. Just try it in F#. You can call that from C#. It just looks like a static class. You won't notice any difference. Try a vertical slice. Take one part of your app and try and go end-to-end from start to finish. Or horizontal tier. I'll do all my business logic in F#, or my data access, or my validation rules. Do it with more than one person, though. If you want to try it in your company today, don't do it on your own because you will be known as the F# weirdo, basically. Don't do that. Get a couple of people. It's much easier than to run with it. Even if you just do 1 hour a week, or half an hour a week even. It's not a lot of time. We do something like this in our company where we just say we allocate once a week or even once a day, every morning or at lunchtime or just after lunch, 15, 20 minutes to learn something new. It's a habit that you build in. Within a month, you'll be fine. How do you learn it, though? You could work with a coach like myself. You could hire an experienced F# developer. You could buy a book. I might happen to have one here. Go to a meetup. Anyone here in London? There's like there's a big F# meetup here. It runs like once a month. You can go and meet people there, talk to them, find out. Port an existing modular app. This is probably the best way I would recommend. If there's something you already know, you know the domain, you know how it works, try and model it in F#. Try and write the business rules in it. You already know how it should work. See if you can transport that across. The official website is fsharp.org. There's some good starting resources. There's a Slack channel. There's also just running now from fsharp.org the mentorship program, which is free. You get basically assigned an experienced F# developer. They'll spend 1 hour a week with you. Doesn't cost anything. Just have to register. There's also a forum, forums fsharp.org, Twitter F#. This is my book, Get Programming with F#. It's a very, very practical guide. I mean, what I went through today is probably the depth of sort of the technical side of things. It's basically just how do I write line of business, proper applications in F#, how do I use NuGet, how do I work with databases, WPF, that sort of thing. How do you convince your boss? If you do try it and you find, well, I can't really convince anyone, don't use technical features. Don't go to your boss and talk about discriminated unions or type inference. It doesn't wash. And it shouldn't wash with you guys either if I'm talking about it now. What you do want to talk about are things like quicker time to market, less bugs, happier developers. This is so important for me. I mean, you've got a team of people working with you. F# makes them happier, at least in my experience. And the fact that there are companies that do commercial support. Even if you don't need it, tell your boss there are companies out there. They've got that as a safety net then. If you do want to try it and you want to go and have a look at F#, I would challenge you to spend 30 minutes just reading up on F#. Just look on a website, won't cost you much. Get a book, make a plan, put in place a process, a habit every day, 15 minutes for the next month. I'll try it. do a .NET new, you can do .NET new console -lang F#, and you'll have an F# app. It's really that easy nowadays on .NET Core. Port an Apple module, start using it. Obviously, that last bit might be a bit more challenging depending on your experience, but it really is doable. So with that, thank you very much. Appreciate your patience. Have we got time for any questions? If there are any? No? Not even one? Okay, well, apart from what a monad is. Oh, God. Yeah, that's why I put that there. But seriously, if you're interested, please contact me. I've got some cards. Would obviously be interested in any of your thoughts. And yeah, take care.